we will discuss even more difficult kind of problem. That's frictional rolling or similar problems. And firstly, we will talk about what this kind of problems present. And then we will use an example to see how to deal with this kind of problem. In this kind of problem, and it's a kind of a rolling problem. But in this kind of problem, if a slipping occurs in the very beginning, you don't know. It could be a rolling without a slipping problem, and it could be a rolling with slipping problem. If it's a rolling without a slipping problem, then at the contact point between this rolling rigid body and the surface, this friction force must be static friction force. Okay? But if it is roll with slipping problem, then this friction force will be kinetic friction force. Initially, you don't know. Anyway, we still can establish our three equations. Okay, the first two for translational component, and here we assume we already know external force P, the driving force P, but we don't know friction force F. Along X direction, we only have P and F. We know P, we assume we know P, but normally the friction force F is unknown, because at this moment you even don't know it's kinetic friction force or static friction force. We also don't know Ag, okay? Along Y direction, we have N, reaction force N, but N may be easily resolved. For the rotational component, if our calculation is about the mass center point G, the expression here, we have one unknown alpha. Okay? So, now, in these three equations here, we have three equations, but 1, 2, 3, 4. 4 unknowns. So we can solve it. So how to deal with it? We will need one more equation to assist us. Now, what we can do? Firstly, we assume no slipping. We assume it's a rolling without a slipping problem. If it's a rolling without a slipping problem, we will know this friction force must be static friction force. If it's static friction force, and if we know mu s, static friction coefficient, can we express the friction force here is equal to mu s times n? Can we? How do you think? Can we calculate the static friction force between this rolling rigid body and the contact surface using this equation? Using this equation. We watched a video in the week before last week when we studied how to determine the friction direction. Do you still remember that video? Okay, let me leave that video again. Have a look.
In this video, we are going to analyze how the coefficients of static and kinetic friction affect the amount of force needed to make an object move. Here we have a force sensor. As you can see, as we pull on the string that is attached to the hook on the sensor, the computer reads out how much force is being applied to the sensor. We will use this to analyze the amount of force required to move carts with different coefficients of friction.
Here we have a cart with added weight on it. This cart is attached to the force sensor through the string. As you can see, we have different carts with different surfaces on the bottom, so we can analyze the graphs of the different coefficients of friction.
So let's look at our free body diagram first. We have our weight acting down on the object, our normal force acting up on the object, and we have our force acting horizontally to one direction, and our friction force acting on the opposite direction. Now, through Newton's second law, we can derive that our normal is going to be equal to our weight, so our friction force equation is going to be equal to mu times mg. Now, if we look at our first part of the graph of our friction force with respect to time, all the way up to the peak, we have our static friction, which is going to be less than or equal to our mu s times mg. And when we reach the peak, our maximum static friction is going to equal our mu s times mg. Now this straight line afterwards refers to our kinetic friction, and this is going to be equal to our mu k times mg. Now if we solve for mu s and mu k, we have our mu s equal to our maximum static friction over mg, and our mu k is going to be equal to our kinetic friction over mg.
Okay, so I hope you have already gotten the idea. For kinetic friction force, you can use kinetic friction coefficient to work out kinetic friction force directly. Okay, but for static friction force, if you know static friction coefficient, you can only work out the maximum available static friction force. But the actual friction force, the actual static friction force, may be equal or may be less than this maximum static friction force. Okay?
Here we have our cork surface cart. The total weight of the cart is 10.78 newtons. As we pull it, we can see the amount of force generated on the graph below. Our peak force value is 5.858 newtons, so the coefficient of static friction is 0.543. The average moving force is 4.786 newtons, so the coefficient of kinetic friction is 0.444. We can do the same experiment with the felt and plastic surfaces. For the felt, the static coefficient of friction is 0.228 and the kinetic coefficient of friction is 0.208. For the plastic, the static coefficient of friction is 0.178 and the kinetic coefficient of friction is 0.127. As you can see, it requires more force to make a cart start to move than it does to keep it moving. It also depends on the surface of the cart. As the roughness of the surface increases, so do the coefficients of friction and the applied force. This allows us to conclude that the force acting on the carts is proportional to the coefficients of friction, and that the coefficient of static friction is larger than the coefficient of kinetic friction.
Okay, now we go back to this slide. I think the answer here should be very clear. You can't use static friction coefficient to work out the actual static friction force. If no slipping, you can't use this equation. But because this is the rolling without a slipping problem, you will have the force equation, and this force equation is the relationship between the mass center point G, also the circle center, and the angular acceleration. You have the relationship between these two, okay, as we discussed in the last example problem. Okay, now, if you assume no slipping occurs, and then you can use this equation for your calculation, you will be able to solve the problem, because now you have 4 equations of 4 unknown parameters. But because you have already made an assumption, and you must verify this assumption. You must check the friction force you will get. If this friction force is equal or less than the maximum available static friction force, then it's okay. But if you find the friction force you can work out is larger than the maximum available static friction force, then this situation is impossible. So that means initially your assumption of no slipping is wrong, and slipping must occur in that problem. If slipping occurs, then it will be kinetic friction force. So you will be able to use kinetic friction coefficient to express the kinetic friction force, and then this will be your force equation. And then you can continue your solution. So that's the procedure for dealing with this frictional rolling problem if we don't know slipping occurs. Okay, so this sounds abstract, and we will use example problem to solve, so we can understand how to solve this kind of problem. But before that, let's review how to determine the friction force direction in rolling motion. Okay, so here you can see there is a vehicle, and this vehicle is moving forward to left side, and we assume this front wheel is a driving wheel, and we assume the rear wheel is a driving wheel. Okay, so now question: what should be the direction of the friction force at point A? So please try using this method to determine the friction force direction at point A. And the vehicle is moving forward to left side. So what's your idea? right side. Okay. Any other answers for the friction force direction at point A? Any other answers? Four steps. Firstly, assume no friction and observe the resulting motion. Okay, for this front wheel, it's a driving wheel. If no slipping, if no friction between this driving wheel and the ground, what will happen? This driving wheel will be rotating, okay? But because no friction, so this driving wheel will not be able to move forward. Okay? The vehicle will be keeping in its original position. This wheel will be at its original position, but only rotating about its fixed axis, so on. Then the contact point in this wheel, the moving direction will be to right side, okay? Because this rotation is a counterclockwise rotation. So the friction force direction should be opposite. Then its direction should be to the left side. Any questions? Any questions? Okay, if no questions, now let's have a look. The friction force direction at point B here. And this is a driving wheel. Okay, it's a driving wheel. Still two steps. Assume no friction at this driving wheel and the ground. This vehicle is moving forward. Okay? If no slipping, if no friction, what will happen? Okay, I got a question here. If the vehicle is moving to the left and the friction is to oppose motion, why is the friction also to the left side? I'm not quite sure which point are you talking about. You are talking about point A or you are talking about point B. Okay, for point A. Now, this is a driving wheel, okay? The friction force to left side. That's why this vehicle can moving forward to left side. Okay? If this friction at point A, to right side, how can this vehicle moving forward to left side? Can you understand this? Actually, for this driving wheel, the friction on this driving wheel is actually the driving force of a vehicle. Why this vehicle can moving forward? No this friction force, no moving forward of this vehicle. Can you understand this? But for friction B, okay, I think you are actually thinking about point B. For this point, if no friction then this driving wheel will be undergoing a translation like a block moving to left side. And then the friction force direction should be opposite to the right side. So you are thinking about point B, but not point A. For point A, this is the driving wheel. This friction force must be as same as the moving direction of this vehicle. Okay, any questions? Can you understand this? Okay, I can understand probably for the determination of friction force in rolling motion is confusing, probably. And probably you need some more time to consider this. Okay, a question again. If the car is a front wheel drive, the front wheels will have friction force going to the left when the car is moving to the left. Yes, that's correct. Okay. It depends on which wheel is the driving wheel and which wheel is the driving wheel. For the driving wheel, the friction on this driving wheel is always, friction direction is always as the same as the moving direction of the vehicle. Okay, that's good. If you can understand this, and then let's have a look at an example problem.